I'm I have a lot of European heritage, and I inherited this nose from the guy who's on the $10 bill. He's my 15th cousin, four times removed. I also have cousins on the first $1 bill and the $100 bill as well. But my Native American heritage is from my great grandmother Hannah. And when I'm doing my ecological restoration work, it's considered land doctoring, where you try to find the treatments and medicines to heal damaged ecosystems. This is the local native tribe, the Ohlone Muwekma, in their dancing regalia, who I've been working with for 40 years. My nickname with them is the seed guy. So land doctoring is needed for ecosystem health. Um, the native peoples, if they didn't have health, they weren't going to survive on this continent. So they had to make sure that the birds were plentiful. This is tidy tips, and the seeds were harvested by California native peoples to eat. Interesting sidebar on the tidy tips is the Portola expedition was starving in 1769, and the seeds from this meadow were harvested to feed the starving expedition. So biocrusts are an excellent starting point to begin that healing process. This is my project in the town of Woodside, Kite Hill, and it's getting healthy after being covered by weeds for decades. So far, I've restored 800 acres of California grasslands. And when I say restored, I want to see at least 95% native cover. And in order to do that, I had to invent what I call my 4 steps. So step 1 is to know exactly what your soil nutrients and what your organic matter needs are in the soils for each plant that you want to grow back, and that includes the biocrusts. So I had a huge challenge in 1993. I was flying into Reno. I was hired by the BLM to restore a 100-mile pipeline north of Reno in the cheatgrass infested sagebrush. But we did 2 years worth of test plot work, and each test plot for each treatment was only 3 by 6 feet, 1 by 2 meters. But if a plot failed, we didn't do that. If a plot succeeded, we tried to find out why did it succeed and then did more. So by the time we were done with our test plots 2 years later, we knew how to plant native grasses. So they all came up and we had 0 cheatgrass. This is our blue bunch wheatgrass after we sowed it 5 years later. No cheatgrass. So this is an example from Kite Hill Serpentine, where I'm working in Woodside. I've done about 80 soil tests, but I take the soil from the top 2 inches or the top 5 centimeters and send it to a lab here in Woodside. I'm in Anaheim, California, called Waypoint Lab. And what they do is what I want to find out is for each plant, what do they need for seedling survival? So if you see at the bottom of the chart here, yellow star thistle and rat tail, those are 2 weeds that take advantage of when an area has been grazed too heavily and the nitrogen stripped out. So it says in the brachypodium grass, it says, thank you for not having any competition because the natives can't grow here anymore. So I'll just move in and take their place. So the surprising thing is some plants have a really wide range of nutrient nitrogen needs. So you see it at 10 parts per million, way at the bottom. The tidy tips can grow, but I did an experiment to see, well, how much do they really want? And my tidy tips were really nitrogen hogs. They said, if you give me 1,000 parts per million, you just pour it on, I'm going to take it, but I'm going to conserve it in my organic matter for later. I'm not going to use it all this year. I'm going to, as if an animal died or pooped near the plant, it's not going to grab it and try to use it in 1 year. So, and then the tidy tips, in order to fight the star thistle, they have to be at a pretty high level. So 250 parts per million to fight star thistles. But if you give them 1,000 parts per million, they're happy as can be. Same thing with the phosphorus. The phosphorus you see at the low level, the brachypodium and rat tail fescue. Say, you let your cows strip out the phosphorus, I'm going to move in, take their place. But then we have the tar plants and the miner's lettuce way, way up at 90 parts per million. And this is serpentine soil, which is technically and historically thought of as being very poor soils. That's not the case necessarily, because each plant needs a certain level. If it doesn't get it, it's not going to live. Same thing with organic matter. Tidy tips can get started at very low levels, but if you want miner's lettuce to come back, you have to have 40%. And then the biocrusts are somewhere in between, which was kind of interesting. You'd think that biocrust could get started in practically zero organic matter, but they need a certain amount to get started. The pH is another issue. I had a huge surprise with the serpentine soil. This is just 14 acres, but I have this huge wide range in pH. And the biocrusts, of course, are making the soil acid where they grow. But for your native plants, if you want something to grow in addition to your biocrusts, like native grasses, like wildflowers, you've got to know what their needs are in terms of the pH as well. So this is one of my challenges at Kite Hill, why we had to figure this out. I had 4 million star thistles seedlings per acre on one spot. This is why I was hired initially by the town of Woodside. Is the ladies living around this area were hand pulling the star thistle for 10 years and not making a dent in it. They didn't realize that it was a soil problem. The star thistle was not an invasive, it was not a weed issue, it was a soil problem. We did soil tests, we added the fertilizers, we added the mulch. 90 days later, 99.5% of the star thistle is gone. The dark part that you see in the picture is the native tar plants growing back. So I don't know if we have star thistle problems in California, we have cheatgrass problems in the Great Basin, and if we just did soil tests and added the fertilizers and mulch, we might get like 150 million acres converted in 1 year. This is where I started looking at the worst of my serpentine area. This is what I call the serpentine barrens. Kids had been riding their bicycles up and down off trail. You can see this white rock in the picture on the left. They cut a hole in the fence there and go spray paint that white rock. So there was like a little highway going back and forth from the trail to that rock, and just wiped out all the vegetation, all of the topsoil. You see right next to the white rock that's Highway 280 that was built in 1972. 2.3 billion cars have driven by since that highway was built. So this is what I was looking at, a completely barren landscape, uh, no topsoil, no vegetation. What the heck am I going to do to restore this? I was thinking, well, I got to go harvest seeds from nearby, and what can I do? So it looked like a lot of our Southwest mining spoils, not a speck of vegetation there. So we excavated a little nearby topsoil. You see that dark patch in the background, that had just weeds growing on some soil there. So we put a half-inch layer just to get some matrix to work with there. And then the topsoil stopped the erosion, but we needed a lot more land doctoring. So I ran the Waypoint lab tests. They have what's called the AO1 and their organic matter. The AO1 just gives you the major nutrients, doesn't give you the micronutrients. But I found that restoring the 800 acres and doing it that way, the micronutrients are usually not the big problem. It's nitrogen and phosphorus and organic matter. So you take 1 quart from the top 2 inches, and then we added the bone meal. So we're adding bone meal, and it's about 1 millimeter deep. So then we're adding blood meal for the nitrogen. Now we're adding, this is the serpentine soil, and we're adding 250 pounds of nitrogen per acre. But then, as I was saying earlier, those tidy tips, if you let them, they'll demand 1,000 pounds. But that's the basic, dose on serpentine in the Bay Area where I'm working. So the fertilizers and the mulch produced an immediate response. We had dormant wildflower seeds still in the soil. We had no idea that they're still there in the barren gravel, the serpentine gravel. And the huge surprise was a 99% weed-free wildflower meadow. This is 1 year later. And all kinds of species that aren't even in the area around them. We had POA coming up that doesn't exist anywhere on the other 14 acres because we haven't fertilized the entire 14 acres to find what else might be in the treasure chest. So adding the organic fertilizers and mulch, the Biocrust started growing back on their own. We did not inoculate anything. They just said, thank you. We've been waiting for somebody to feed us. We've been waiting probably 150 years. Somebody's finally started to pay attention to us. So using the Waypoint lab and we ran these, what I call the paired tests. So I have an area that has Biocrust growing, and then about 2 meters away, go and take a sample where the Biocrust isn't growing and compare the two. See what the Biocrust needs in terms of nitrogen, phosphorus, organic matter. What's missing where it's not growing. Same thing with the native plants. So I go out in the field, I got my 1 quart or 1 liter plastic bag, my narrow bladed trowel. I like the narrow bladed trowel because you can take out big rocks before you put it into your sieve. And the sieve, 1/4-inch mesh or 6 millimeter mesh, and a plastic paper bag. And that's useful for not only carrying out your materials, but to sift your soil onto, and a pen or marker to mark things. So I'm getting my Biocrust, I call it Biocrust plus soil sample from the top 5 centimeters. And you always include your Biocrust in your sample. So you go a couple meters away, get your, this is the, this is that barren serpentine at Kite Hill, uh, probably full of asbestos. You get your sample and sift it and include your biocrust, crush up your biocrust, take out the big rocks and if you get roots or plant material. So this is the biocrust minus test. So I'm ending up with, and this is right next to Highway 280. So I'm ending up with only one in from the top 2 inches, five centimeters, 1 part per million of nitrogen, 2 parts per million of phosphorus, organic matter, surprisingly, in that barren soil is still almost 3%. A lot of my soil tests out in the Great Basin, if you had 3% organic matter in the deserts, you're doing good. So to compare that with, and then I like this format that the Waypoint Lab gives you. This is called their bar graph format. So their optimum levels that they're showing on these soil tests is actually for California soils, not for corn farming in Iowa or soybean farming in Illinois. It's for our soil needs. So if you see something in the red zone, um, you know, um, you know, that's where you need to fix things usually. So this is from the Biocrust Plus site nearby. So I'm up to 5 parts per million nitrogen, 6 parts per million of phosphorus, and the organic matter is almost double. And you see the weird thing about serpentine is the calcium magnesium ratio. So the magnesium's off the scale compared to the calcium. So here's the fine line that we need to cross to get Biocrust to grow back on serpentine in California and Northern California. I only have to add 4 parts per million nitrogen. That's nothing. 4 parts per million phosphorus. That's nothing. Add another 3% organic matter. That's a little, but you need to take a look at your calcium and magnesium also to see if that's within the thresholds needed by the Biocrust. I think that we could regrow Biocrust anywhere on the planet without inoculation, just by feeding the Biocrust what they need. And if you want wildflowers, I tested the wildflowers nearby. They just needed a little more also than the Biocrust. So you can go from Biocrust to wildflowers to native grasses in very easy steps. The interesting thing, I started doing non-serpentine Biocrust plus and minus soil tests to get the thresholds in relationship to different rainfall, annual rainfall amounts. And it seemed to, at least in my part of California, go pretty evenly, straight line increases of the nitrogen, phosphorus, and organic matter in relationship to the annual rainfall. So if you're working on Biocrust somewhere and you can go from one rainfall range to another and maybe make a chart like this, sort of a cheat sheet to say okay, if I go from 8 inches to 16 inches, I need to make sure that I'm doubling up on my nutrients and everything. This is what we found when we were doing the 100-mile pipeline north of Reno. We were starting at 8 inches of rainfall, but at the Seichen Summit at the border of Lassen and Modoc County, we were at 12 inches. And that's where we found our only Biocrust in the whole 100-mile pipeline route, but it was really thick mosses. I was really surprised to see out in the desert these really thick moss biocrusts. That's the first time I had really encountered them in my restoration. So this is the either the good news or the bad news. The atmospheric nitrogen deposition theory is dead. This is my best wildflower area in the whole preserve. It's within a stone's throw of Highway 280. When I did my soil tests, where 2.3 billion cars have driven by since 1972, I only had 1 to 5% parts per million nitrogen. It wasn't enough even to get the biocrust to really grow. I needed to add a lot more. And so don't be afraid to add nitrogen to any soils. The plants need it, the biocrusts need it. Just find out what they need by doing your soil test and give it to them because they're starving right now. So here's what I looked up online from I Ask AI. What's the current thinking processes if we don't add the nutrients or the organic matter and we try to let them regrow naturally? Well, the thin cyanobacteria crust, 5 to 7 years. The growth and repair, maybe 50 years. The lichens and mosses, maybe hundreds of years. Full recovery, maybe never. Run your soil tests. Run your paired soil tests. Set up your fertilizer and mulch test plots. I think everyone attending this meeting and anybody who watches this in the future, you could get biocrust to grow back in 1 year without inoculation. And you could get everything else to grow back, like I did when I added the fertilizers and mulch to get that wildflower meadow to grow back. You're going to be surprised at what dormant seeds we still have in the soils here in California and maybe elsewhere. When I add the fertilizers and mulch to Kite Hill, the dormant native seeds are coming up at the rate of 5 to 10 per square inch. And I have a new species of stipa that's popped up. So don't wait for a huge grant to try my method. This is my students. I've been hired by Kenyatta College to teach the environmental studies students my methods of restoration. This is where they're setting up their tiny test plots, 1 square meter. We set up 13 plots last September. 4 of those plots produced 100% native cover, and we didn't sow any seeds. It was dormant seeds in the soil once again. And they came up and fought the weeds. And we were getting rid of star thistle at the same time with this fertilizer method. So don't wait for the big grant. The grants may not, with the way that the federal government's going these days, we may have to all be citizen scientists, but we can still get this information for a few $100s and find out how to do land doctoring in our own area, and then partner with people who need the land doctoring and get the party started that way. We shouldn't waste time on test plots. We need to use the methods that seem to work and get the party started in a big way. So if you think of biocrust like a culture growing on a petri dish, this is how I look at, where I'm restoring them. The agar base is the organic matter that's on the surface of the soil. If they don't have that organic matter base, the nutrients don't have any place to stick, and they don't have any place to stick. So the nutrients that are mixed with the agar are the nutrients that you're going to add after you've done your soil tests. So I love this picture it kind of looks like the biocrust, but on a microscopic scale. So here's how I look at the restoration that I'm doing and how I encourage the Saudis to look at their 1 billion acres that they're working on right now. You start with your organic matter. Is it right? Is your nitrogen threshold good? And is your phosphorus threshold good? And then see if you can get your biocrust restored that way. But you may find that your annual native grasses and wildflowers might get restored first, like they have at Kite Hill. But either way, your soil starts getting stabilized and insulated, and you stop the dust storms. I think this is the key to our survival as a species on the planet, is we have to insulate the desert areas, stop that heat from getting into the air where the CO2 can trap it, stop that dust from getting into the air, which can also trap heat, and wind down global warming that way. Trying to suck all the CO2 out of the air and cool us down is going to take decades to centuries. You put an insulating layer of biocrust, native plants on barren desert soils, like the Saudis are doing, you stop the heat immediately. You turn it down. So then the other thing that we overlook, the biocrust, a lot of people are looking at and talking about, but to me, the gill fungi and the slime molds really need to be examined as a key part of our arid land ecosystems. And then you go up from there, the native grasses, perennial forbs, and get some biodiversity in your annual and perennial plants. So, you don't want it just to have a monoculture of X, Y, or Z plants. The other thing that the Saudis are thinking about now is the Pseudomonas biorain host plants. So this has only been discovered in the last 10 or 15 years. Our rain is mostly nuclei by a bacteria, Pseudomonas. And it lives on leaves. It gets airborne right after a rainstorm. It goes up into the air and it grabs moisture and forms a new rain cloud. So if you're looking at a forest right after a rainstorm, you'll see the Pseudomonas getting airborne. It looks like somebody started a little campfire and it goes straight up out of the forest and then forms a new cloud. And any place that's called a cloud forest, that's actually a Pseudomonas host plant area. So we could take arid lands like Arabia or like the Southwest, find out which biorain plants live there and plant more. So that's the plan with the Saudis and some of the other 24 countries that are part of the Middle East Green Initiative. They're going to plant 50 billion trees altogether, but now they're looking at if we plant part of those as biorain trees, that will help all the plantings that we want to get watered naturally by natural cloud seeding. So you go up from there, shrubs and trees and insects and birds and mammals and large mammals. And I would include at the top number 18, native peoples. So, having native heritage myself, it'd be nice if the native peoples were included in the restoration and the management and this whole process too. Because the native perspective can add to the whole project being successful. So this is an example of what the Waypoint Lab take-in sheet looks like. It costs $100 for the paired tests. And that's if you want them to send it back to you. Normal is 5 to 7 working days. And it's that simple. $100 gets you in the door and find out what you need. So this is one of 4 tools that I've had to invent to restore lands. This slideshow is at ecoseeds.com/biocrust or back.pdf. This is an example of what we could do anywhere in arid lands. This was a weed patch just a few years ago in Woodside at Kite Hill. We fertilized, we mowing the weed grasses so they don't reproduce. That's all we've done. 2 things. No seeding. The seeds are there, ready to go, waiting for somebody to come pay attention to them. So this is my email, and if you run your paired tests, email me copies. I'd love to see what other areas and their Biocrust plus and Biocrust minus threshold look like. So that's it.
Awesome. Thanks, Craig. Before I get into folks, if you have any questions, you can put them in the chat. I saw that there was some questions in there. I just want to start off with you. I thought it was interesting. We talked about this before about the lack of nitrogen deposition from the road, and you make recommendations to add nitrogen for the Biocrust, but that's like in the desert Southwest, kind of more east of where you are. Most people would be totally against adding nitrogen because sort of the dogma is that the second you add nitrogen to an area, you're going to get invasives. So what do you have to say about that?
Well, let's talk about that. That's why I was showing where the highway was putting nitrogen in, but I was only getting 1 to 5 parts per million after 50 years. If we hadn't put nitrogen in the desert soils north of Reno, we wouldn't have had the natives be able to beat the cheatgrass. So you can get weeds to grow, but in order for the natives to succeed over the weeds, they have to have the energies to produce allelic chemicals. So the way we fought the cheatgrass on a 100-mile pipeline was we fed the natives enough that their seedlings produced the allelic chemicals that suppressed the cheatgrass from ever sprouting. And it's done that method for the last 30 years. If you go and take a look at the pipeline, which is along 395 between Susanville and Alturas, that pipeline 30 years later is still 95% native cover. The weird thing about adding nitrogen is there's actually 3 different levels of adding nitrogen. So your first level is for your seedlings just to sprout and survive, but you could bring up weeds at that same time. But until you get to where your natives can suppress the weeds is the critical tipping point. So we have to stop being afraid of, if the soil test tells you you have to add nitrogen, you have to add nitrogen, and you may have to add more nitrogen than your threshold's telling you about.
It's going to make a lot of people really uncomfortable, which we love. Okay, let me get to some of these questions. Mackenzie asks, do you think application of fertilizer is needed on these sites? How often?
Every site on the planet, wherever you've had domesticated animal grazing, we've stripped out the nitrogen and phosphorus and organic matter below seedling thresholds for natives to survive. Here's an easy way to test my theory. I don't want you to be afraid of like my students, I'm afraid to even put nitrogen on a 1 by 1 meter test plot. I might destroy the environment. You go and take some soil from your site where you want some native to grow. Pick a native, a wildflower, easy to grow. Poppies are my favorite, California. You take that, this is how we found out why we had to have nitrogen on that 100-mile pipeline. I took soil and put it in two boxes. One box, I sowed native grass seeds, no fertilizer. Second box, added the fertilizer and organic matter. First box, seedlings grew 2 inches tall, died of starvation. Second box, seedlings grew fine. That's why we had to add the nitrogen and the organic matter. Without it, you do your test in boxes. If you're too afraid to put it out in the field, see that they die without being fed. It's that simple.
And what
6
about
months.
reapplication? So following up with applications.
Um, you mean if the soil's in boxes?
No, I think out in the field. So the question was about
Oh,
reapplication of fertilizer.
oh yeah. Here's the paradox of that 100-mile pipeline when I went to see it 30 years later. We put down enough nitrogen and fertilizer for that first generation of seeds that we sowed, but we didn't put enough down for a second generation. So now we have 100 miles of beautiful native grasses, 95% native, but they're old plants now. They're producing seeds, but we didn't put that extra in the soil at the time so that their seeds could survive as seedlings. So this is the paradox of us being afraid of nitrogen is we might put down enough, we look at some place for 30 years and then we realize, oops, there's not enough for a second generation. That first generation is going to age out, disappear, because we didn't put enough down the first time.
So in that case, do you recommend sort of maintaining resources in the chance that the following year, 3 years later, you're going to need to reapply and then actually applying that for that next generation?
Absolutely. There's places that cut and depends on what weeds you have to fight. For example, the star thistle, the threshold for star thistle is pretty high to have your natives strong enough to fight the star thistle by themselves to suppress those seeds from ever sprouting in the future. There's one area that it disappeared in 1 year, but there's still little place you can't ever cover an area completely. It's like putting that first coat of paint on some bare wood. It soaks in at places and doesn't soak in at places. So I've had to reapply just to pick up the stragglers on the star thistle. I've had to fertilize that place 3 times now. But we went from 4 million star thistles to, a few hundred star thistles to, a few dozen star thistles. But you really want your area, wherever you're restoring, Biocrust or native, you want 95% native cover if you can. That should be your goal all the time.
Agreed. It's a great goal. Okay, Shane asks, could it be as simple as spreading your extra compost to encourage crusts?
Yes, that's what I'm experimenting at Kite Hill on this. What's left of the Serpentine Barrens right now. I'm just adding mulch with no fertilizers, just to see if that'll do the trick. Because you see with the nitrogen and the phosphorus, it's saying the difference between zero crust and plus crust is only a couple parts per million. There might be enough of that or nutrient in your compost already that you don't have to even fuss with that. So every every test plot, I'm hoping everybody will go out and do their soil tests and do their test plot by this fall. I think that if you do 1 meter square, 2 meter square plots, but do several different treatments, mulch by itself, add a little this, add a little bit of that, add a little more, see where your sweet spots are. You might get by with just plain old compost and call it a day.
Cool. Shane also asks, any advice for folks working out here in the southern and western Iberian Peninsula? We have pockets of beautiful biocrusts. And I think associated with that, it's like, how well do you think that this will work outside of California?
I think it'll work anywhere on the planet. Anywhere on the planet. You get your thresholds nailed down, you do your multiple test plots on small scales, and and when you hit the mark, go big. That's how we had to do it for that 100-mile pipeline. Over a 2-year period, our 1 by 2 meter plots, we had to do about 100 different plots to find the sweet spot for the 5 different native grasses we wanted to grow back in that cheatgrass area. So the first year, and don't get discouraged. Our first year, we had 97% failure in our test plots. But we looked at that 3% that worked and found out why did the other 97% fail. And then by the time second year rolled around, we had 100% success. And what I mean by 100% success, we had 0 cheatgrass in any of our plots in the second year. I was hired by BLM, and the pipeline company had hired a big consulting firm. We told them what we had to do on that 100 miles. We said we have to do this and that. And they said, that's not in the scientific literature. We've never heard of anybody doing it that way before. And so we said, well, let's set up test plots and we'll split the same sack of seed. You plant it your way over there and we'll plant it our way over here. And whoever works out the best is how we will do the whole 100 miles when we come back 6 months later. We came back 6 months later, looked at our plots. We had 100% native grass, 0 cheatgrass in any of our plots. We looked at their plots. They had sown the exact same seed in their plots. They had 100% cheatgrass in their plots, not a single native seed. We said, which way do we have to go? They went our way. 30 years later, that whole 100 miles is still 95% native cover. So use your test plots, use your soil tests, get started, and then go big. Go big. We need to go big right now in every place we can. The earth needs our land doctoring, and we got to test out our land doctoring methods and use what works.
I love it. Jim asked, are there any specific erosion control techniques you use to prevent runoff of the fertilizer or the mulch?
Well, when we first fertilized the barrens, we had a torrential rainstorm in February that year. And so we had to reapply it on that slope. People add psyllium powder and different tackifiers to hold things on slopes. I would just depend on coarser compost, to tell you the truth, because you add a tackifier and that could affect the small little things that live in there. They could get stuck in that tackifier. I don't want to come back and be the killer of, the ants or whoever else is trying to roam around in that area. So the other thing that we found sowing the seeds are the granivores, especially the rodents that can smell the seeds. we planted our original test plots in rows, and within a week they came and dug out every seed out of every row. So what we used is we used raw sawdust mixed with the seed, and they couldn't find it that way. We also didn't sow in rows. We broadcast the seed, and we also didn't use any seed mixes because you want the allelochemicals of the natives to fight the weeds, not to fight each other. So we sowed all of our 5 different seeds in a mosaic. So we'd have an island of this grass next to an island of that grass. But each different species had its own nutrient levels that it needed to grow. So the poa and the squirrel tail, you fed it a little lunch with the sawdust to grow. But if we wanted the Great Basin wild rye or the blue bunch wheatgrass to grow, we had to feed those 2 grasses a 5-course meal with the nutrients. So each native's going to have its own needs, and you never make seed mixes, and you don't be afraid of adding nitrogen because the soil needs it.
Cool.
Any other questions?
This was awesome. If anyone has any other questions, feel free to throw them in the chat. Oh, Kelly. Kelly came in and says, I recently volunteered in an area where there was a natural spring in the Sabino Canyon area that's right near Tucson, Arizona, and is being overrun by arundo. We were digging up the arundo roots, which are huge, and constantly cutting down the growth. The area was pretty rich with plant life because of the spring. Do you think some kind of soil amendments like this help encourage growth of native plants and discourage the arundo?
Well, thank goodness the only perennial that I have to deal with in my part of California is harding grass. I wouldn't know how to tackle that, but still you should test the natives that you want to grow back, find out what those thresholds are, and see if the arundo is growing in lower nutrient and lower organic matter conditions than the natives are, need. So think that your desirable plants are going to have a certain level, and if you have a weed that you want to get rid of, is your soil up to accommodating the native that you want to grow back in its place?
Excellent advice. Well, I really appreciated this, Craig. This was awesome. It's always excellent to hear from practitioners who are doing the work on the ground and really seeing results after a long period of time. So this was super helpful. And for everyone else, we really appreciate you guys joining us. I did put Craig's email in the chat, but I'm also going to follow up with everyone that registered with Craig's email, the waypoint testing, and the link to the recording. So if you guys need to reach out to Craig, you will have his information. So let's thank Craig once more with your, I don't know, your reaction emoji thingies if you want. And we'll see how we move forward in the future. Thanks so much, Craig.
Thank you.